uh, current division rule. What is current division rule? In electrical networks, we have two types of connections. One is your series connection and the second one is your parallel connection. In series connection, there is voltage drops. When the components are connected in series, voltage drop occurs at the components. That means the total voltage is equal to the sum of the voltage drops across the components. So you should remember that in series connection, the current remains the same, but the voltage varies. But what happens in parallel connection? In parallel connection, the current changes, but the voltage remains the same. Okay. So you should remember that in series connection, the current varies, the voltage varies, but the current remains same. But in parallel connection, the voltage remains same, but the current varies. Okay. So which rule we generally apply in case of series connection? In series connection, we apply the very famous rule KVL, Kirchhoff's voltage law. Okay. In series connection, we apply Kirchhoff's voltage law. But what happens in parallel connection? In parallel connection, you cannot apply Kirchhoff's voltage law. Here we have to apply the current division rule. Kirchhoff's voltage law is called voltage division rule, voltage divider rule. That is the total voltage drop across the different components connected in series is equal to the component of the source, the voltage of the source. If there is no source, then the sum of product of current and resistances is equal to 0. We simply multiply current with resistance. That means you simply apply Ohm's law. Remember, Ohm's law is the basic law which we apply to electrical circuits. Okay. Ohm's law is the basic law which we apply for electrical circuits. All other laws, they are based on Ohm's law. KVL, Kirchhoff's voltage law, it is nothing but the Ohm's law, derivative of Ohm's law. So, in series connection, voltage divider rule can be applied. But what happens in parallel connection? Suppose you have two resistors connected in parallel. Two resistors R1, R2, they are connected in parallel. Suppose the current given to the parallel combination of resistors is equal to I. If the two resistances are equal, if R1 is equal to R2, or the magnitude of resistance of R1, suppose say R, and magnitude of resistance of R2 is equal to R, equal value of resistances. then what will be the current through each registers? If you supply current I, then what will be the current through each registers? It will be equal to I by 2. In R1, you have current I by 2. In R2, you have also current I by 2. Equally, the current will be divided because the two resistances have same value. So the opposition or the current of by the two resistors will be same. But what happens if the two resistors are not equal? R1 is not equal to R2. How we can find out the currents, that is I1 and I2? Suppose I1 is the current passing through R1 and I2 is the current passing through R2. So how you can find out I1 and I2 in electrical circuits? This is a basic problems for the students. Okay. So what you will do, you apply the same rule, same basic rule, that is the Ohm's law. So how you can apply the Ohm's law and what will be the current? Let us explain. Let us discuss. First, I am talking about the mathematical part. Then I will talk about the physical part or physics. Since in parallel combination the voltage are same, in both the resistors the voltages are same. That means at the two terminals of the connection, the voltage drop for R1, R2 and also for their equivalent resistance will be equal to same. That means for R1, if the voltage drop is equal to V, for R2 the voltage drop is also equal to V, and for their combination, that is for R1 and R2, for their combination the voltage drop also will be equal to V. Is not it? So if the current supplied to the circuit is equal to I, then what will be the effective resistance of the parallel combination of R1 and R2? Apply the simple formula 1 by R1 plus 1 by R2. 1 by R will be equal to 1 by R1 plus 1 by R2. So the effective resistance will be equal to R1 R2 divided by R1 plus R2. Is not it? So if you multiply the effective resistance with the current, then you will find out the voltage. And the same voltage drop will occur across R1. So what will be the expression for the voltage drop for R1? It is I1 into R1. Since the two voltage drops are same, then you write the equation I1 into R1 is equal to I into R1 R2 divided by R1 plus R2. So what will be I1? So I1 will be equal to I times R2 divided by R1 plus R2. Is not it? So you can find out the value of the current through R1 in terms of R1, R2 and I. If voltage is not given, value of the voltage is not given, then you can also find out how much current is flowing through R1. Similarly, what will be the value of current through R2? Very simple. It will be equal to, suppose I2, that will be equal to I multiplied by how much? R1 divided by R1 plus R2. Very simple. So in parallel combination, if voltage is not given, in parallel combination, if the voltage is not given, only current is given, in this way you can find out the current through each resistors. Okay, and this is called current division rule. How you can find out the current? How the current is divided through the resistance. This is the current division rule. Now let us go to the physics. Why the current is divided through the resistance like this? Remember, current always need a easy path to flow in a circuit. Okay, current always need an easy path to flow through a circuit. When the path of the current will be easier, if the resistance will be small. If the resistance will be small, then it will be easier for the current to flow. And in parallel combination, how the resistance, you can make the resistance small by taking the reciprocal. We know by taking the reciprocal. If you take the reciprocal value of the resistances, then only the value of the current will be large, because the opposition will minimize. That is why in the resistor you are getting more amount of current due to less amount of resistance. Okay. For R1, what is the resistance? For R1 resistor, what is the resistance? R2 divided by R1 plus R2. So this will be minimum. In the circuit, if you have two resistors, this will be the minimum resistance. Is not it? So this method is very useful in electrical circuits. Generally, in the syllabus, you have voltage division rule, that is the KVL, Kirchhoff's voltage law. In most of the syllabus, there is no current division rule. You should remember this formula, these two formula, while you solve the different problems in electrical networks. The first formula, voltage division formula, where you apply Kirchhoff's voltage law, and second formula is the current division formula. That means if you remember only two resistors, simple circuit, then you can draw more complicated circuit to find out the respective currents by the application of the current division rule. Okay, so these two rules are very important in electrical networks. Thank you.